Hello, everyone. So this is Montana Williams. I am just setting up the Arduino workshop right now. Just give me a hot minute before I get things started. This is gonna be really fun for all of us. Let's see. Is it broadcasting to the right place? Isn't it going anywhere? How would I know if it's going to the right place? Let's see. CSE Club. All right.
Hello.
Oh, hello.
Hello. I'm checking really quickly to see if the live stream is working yet. Let's see if it is. Did it? Okay. It is recording anyway. I just really want to make sure that it's working right. So thank you for second opinions. How often is 10 seconds? I got the right key, right? I know. Andrea had just texted me right now, too. Is it up? Oh, no. Oh, no. I'm even more behind. No. Okay. Let's see. It's there now. A general meeting? Oh, no. That's not correct at all, is it? How can I change that? Let's... How would I do that, though? Oh, I need access to the YouTubes. Is that right? I only have the key. Unless... Yeah, no. I only have the key. Whatever the name is on the YouTubes is probably different. This is where I call up Andrew and ask him for information. Informaticals. It does work, it looks like. So, in that case, I'm going to take some time off. Let me go ahead and get that fixed then. Really quickly. Let's see. Wait. Oh, actually, I can ask Andrew to do it. I can ask him to change the name. Can you change the name of the YouTube? I'm sorry, what? Yeah. Oh, yeah. We can do that maybe tomorrow or Saturday or Sunday or tonight. Oh, even better. That would be better, yeah. Does Instagram not like links or something? Does Instagram not like links? Switch to professional account. Okay. Stuff. Hold on. Okay. This is an interesting development. unfortunately, it looks like well, I'll have to figure that out later. But just to get the live stream working. There we go. Alright. Fantastic. It's not a link. This is very interesting. I'm just trying to make this work out. Because I want my friends to come here and check it out with me. For the record, they cannot hear you on this. So okay. Mm-hmm. Don't worry, it happens because it's me. Totally. I see. Gotcha. Instagram just broke. You have it on the website, right? Oh my god. This is why you don't make your Instagram public. Oh god, all the 150 follow requests that I never wanted and never declined have now been accepted. Unbelievable. All right, whatever. There will be. Hold on. I'm just getting it set up right now. I do have a BRB sign right now. Okay, but all right, let's get this show on the road. So, all right. Hello everyone, my name is Montana, and today you're going to check out the Arduino workshop hosted by Computer Science and Engineering Club at Cal State San Bernardino. Now, before we get into what the workshop is about, we need to ask the question, what is a what is an Arduino? I'm sorry guys, I'm going to have to like leave you guys behind. All right, bye. Okay. Sorry about that. So we need to ask the question, what is an Arduino? An Arduino is this little guy right here. I want to show you. Bam. Wow, what is it? It is this blue thing right here. It's a controller, a microcontroller of some sort, which lets you write things for circuits and electronics. You can read things from sensors as well, and it's the most generic way you can possibly have to write and implement data for your circuits and stuff. So just to give you an idea of what this is, let me tour you around what this device looks like. So let's get in even closer. Let's see. All right. So on the Arduino here, what we have are, we have this pin right here. This controller. This is an Atmega 35. I can't recall the name. Oh goodness. I can read it. You tell me if you can read it too. Oh yeah, it's a 35476. Sorry, Oh no, everything's falling apart now. Sorry, my hype has just been destroyed. Okay, without complicating things too much, this right here, this is the microcontroller. This is the thing responsible for sending things to, sending signals, reading signals, and basically interpreting all kinds of data. So, but this is basically an entire CPU, an entire chip. What the rest of this is a way so that it can communicate with this thing much more efficiently. Using this CPU, this tiny CPU basically does the bone work to make this thing act as a CPU, talk faster or talk more effectively. Now that's what I believe. I researched right, I think. Besides that, it's a rewritable microcontroller, and it has an interface right here with USB Type B. So you can upload this to a computer, send code, and it'll interpret that code and it'll translate it directly onto your circuits. These pins right here on the side are what is allowing it to send signals and communicate. So let me tour you a bit around. So right here on this backside, these are the power pins. So there's a lot here, you can probably see. Okay. So right here are the power pins. So these, because you're taking power directly from USB, you're allowed to distribute it a bit through these pins right here. So here we have a ground pin, and here's a 5 volt pin, a 3.3 volt pin, a reset button. I don't know exactly what this one isn't. This one is, and then voltage in if you want to regulate your own, I suppose. Over here we have analog pins. So digitally, you can describe a bit as a 0 or a 1. Analog lets you describe it in a range between 0 and 1. Given that, then you are allowed to read sensitive data, such as a sensor where it's light sensitive. We'll get to that later on. Or you can read resistor values, like from a potentiometer, and other things like that. Basically, this lets you get float data by enabling the pins to be accepting or sending analog data. On this other side here, we have digital pins. So these first two, 0 and 1, you don't need to worry about. 2 all the way to 13 are all digital pins. These digital pins are exactly what you imagine 0s and 1s would be. If it has a high value, it's a 1. If it's a low value, it's a 0. This is what we're going to be dealing with for this workshop. And we're going to be basically implementing a counter. How does this thing work, though? All right. That's the question. All right. So if I want to use a counter, I guess the first thing I got to do is make sure that I have an idea on how to use this thing. So let's try to practice. Oh, I'm sorry. Before we get going, I forgot that you guys can also participate using an online simulator called Circuits by Tinkercad. All right. That way, everyone can participate. It'll be really cool. It'd be nice. I think it's free too, so you don't have to worry about how it works out. Let me go ahead and share my screen. What you want to do is, let's see. Nope, that's spoilers. Okay. So if you go online and look up Tinkercad online Arduino, Tinkercad Arduino simulator, then you'll immediately get pulled to this link, circuits on Tinkercad. Go ahead and follow the link. I'm already signed in, but you need an account to participate. Okay? Then you want to go down to Launch Tinkercad Circuits. And when you do, I would ask you to sign in and create an account with Autodesk. Autodesk does all kinds of other things related to hardware design, integrated circuits, and everything like that. Basically, they love hardware, and they like demonstrating what hardware can do. And especially taking an approach on education, which is why this simulator exists. Okay. Now that we have the simulator up, whenever you get this ready, on the right-hand side, you have a lot of options. You have hardware devices. Because I'm using an Arduino Uno for physical demonstration, you guys can go ahead and use the Arduino Uno as well. What you do is click and drag over to the center here, and then you can see that you have your own Arduino to work with. You can press Control and then your scroll wheel to zoom out and then move it around a bit more. So let me say that again. You can drag it out from the right-hand side into the center window here. Then, if you want to, you can hold Control and then use the scroll wheel to shrink the entire screen down. Okay, so now that I have this Arduino ready, I have nothing connected to it. Right next to it, you might have seen that I had a breadboard, right? So this breadboard is what is a convenient way for us to play with circuits without having to design it in advance and solder it in. We can kind of play with this thing as much as we want. So back into Tinkercad and circuits, we can go ahead and drag a breadboard of our choice. I'm actually not going to use the small one. I'm going to search for breadboard and use a full-length breadboard. Okay? I am using a small one, but that's only because things barely fit, and the more space that you have, then you can probably get around with how you feel with it. Okay? So now, what I want to do, let me go back into real life. All right. What I want to do is create an LED. Oh, I'm sorry. I'm not done with my explanation of breadboards. All right. So how do you read circuits? How would you pin things out on a breadboard? Okay. So what you can do, on this side right here, the plus and the negative, this is going to be your power rails. All right. So this is literally where you're going to establish where your current, your voltage starts. That's going to be the plus. And then once you're done with everything in the circuit, or if things need to go to ground, that's what this negative rail is for. So you can attach anything to it. Now, notice that I'm gesturing this way, up and down. This power rail goes from top to bottom, but it's disconnected from this ground rail. This is also vertical, but it's disconnected and doesn't touch the positive power rail. Okay? And these are the only the only rails on this breadboard which are vertically attached this way. So, the difference here in the center is that each row is connected. So if I were to touch something into this top right hole in row 1, column E, it's the same thing as row 1, column A. Okay? But if I have something connected in row 1E and something else connected to row 2E, they are inherently disconnected. They are not the same rail. They're not the same connection. And so each row is separated. So there's 30 different rows for us to play with on this breadboard. On the other one in Tinkercad, we have, let's say, that's 60 rows. Granted, this is also labeled horizontally. Mine's is labeled vertically, but the idea is still the same. All right. Now, if we want to look at the columns, then of course we're going to say that I can make a circuit connect by attaching a rail or a wire from 2 to 4 so that I can continue things going on. You're allowed to do this, and that's how we'll connect an LED to work on this Arduino. Okay? So now we're going to get into the Arduino and how to make an LED light up. So for this, you're gonna need a resistor. I have 220 ohm that's labeled incorrectly. That was only because of my averages. A 220 ohm resistor, an LED of your choice. This is my goodie bag, so it actually has everything we're gonna need in this workshop. I'm gonna grab the blue one because for some reason my blue LED is really bright and it should make it super obvious that we're correctly wiring it. You're gonna need power cables. So I twisted mine together, so this will connect and give us power and ground it. And it has enough length where we can set up the power rails on this side. Okay. And I have small wires right here. This will just help me wire things up to this thing. Otherwise, you can use wire like this to physically attach them, which are easier to attach, but it is still a bit bulky vertically. So that's why I have these ones to help me make this look cleaner. And on your screens, that's how you will be able to see it. Now, back on Tinkercad, if you want to establish a wire on each of these pins right here, let's say we're going to have 5 volts out, okay? I want to have the 5 volts and the ground pin connected. So if you see this right here, let me zoom in. Okay. Where am I at? Okay. So the ground pin and the 5 volt pin are going to be attached to the red and black pins. Okay. You've probably seen before that red represents positive and black represents ground. Okay. So I'm going to go ahead and plug these ones in to the 5 volt and the ground pin. Okay. Let me show that again. Okay. There you go. So I can even put more space so it's more obvious which one is which. Bam, bam. Okay. Meanwhile, all the way out over here, I have these leads to go, and they're supposed to connect into the power rails for the breadboard. Okay? Okay. So, all I gotta do is attach these into the power rails, and we're good to go. Bam. Now, this isn't plugged in yet. The Arduino doesn't have a battery of its own, but so I would have to plug in my USB Type B cable for it to get power. For you guys, if you're doing this online, you don't have to worry about any of that. It's only a simulator, so it already has its own way of having power. Okay. Let's go back onto Tinkercad and show you how you can establish this as well. So I told you you can highlight the pins right here. If you left click, then you can drag a wire out. Now you can just drag it into the power rails over here, or you can also wire it kind of fancy. And you can do this by left clicking again by adding a joint. So I'm gonna have this thing joint its way over here, and make sure when you're plugging it into the hole that you see the highlighted square around it. That means you actually did connect it. By default, this simulator has green wires, but you can change the wiring on the right hand side, or by having the whole wire selected and then changing its color. So I'm going to change this to red. Meanwhile, the ground pin is going to be wired over here into the ground pin. So this will be black. Okay. Back to reality. This is what we have now. I want to attach the LED here in a way where I can finally get this thing working. Now, I did say you need a resistor. LEDs are a bit strange. They need they only operate at a specific current. So we can get into physics later, but really all you need to know is that to make the LED work, you're going to need this thing. This thing right here is my 220 ohm resistor. So for a close-up, this is what we have. Okay? They have color codings on it, but ultimately you don't need to, you could figure them out yourself. You can identify them, or you can do what I do and do the cheap way out and get a multimeter. So let me get my multimeter right now. Give me a second. Okay. All right. So let me move my Arduino out of the way. This is a multimeter. If you're doing this in real life, with real hardware, you would need something like this to identify all kinds of variety of things. So a multimeter can help you identify voltage, resistance, and current. Some of them also have options for alternating current, but we don't have to worry about this because for the things that we're dealing with, we have a mainly only direct current. That's what this is. So let me zoom out just a bit more. So on my leads, I have alligator clips. These alligator clips will help me attach them to the resistor I have to verify that this thing is a 220 ohm resistor. Okay? So first, what I want to do is turn on the multimeter to the this section down right here. This is ohms are represented as the resistance values, and they're also denoted using an omega sign. So if I were to read this, in this section right here, I'm trying to figure out small values of resistance up to 200 ohms. Okay? And then here, this has a tolerance of 2 kiloohms, which is 2000 ohms. Then this here has 20 kiloohms, up to 200 kiloohms, and then 20 mega ohms. So because ours is kind of small, but I did say this thing is 220 ohms, if I was on the 200 resistance values, then I shouldn't be able to read it. And we can identify that by checking it in. So I'm going to attach the leads onto this resistor here to make sure that this is actually a 220 ohm resistor. So first thing I do is attach ground, because this ground isn't completing a circuit at all. It's safer to do that, and then you can hold it, and then you want to attach the positive side to this. So reading a multimeter, you see that I get a value of 1 here. That's basically like an overload error. You cannot, it's outside of the range that it can identify. So because this is 200 ohms and we're expecting this thing to be 220 ohms, then I want to switch to the next one. So what it does is it moves the decimal place and identifies this thing as written in kiloohms. So 0.219 kiloohms is the same thing as saying 219 ohms. And for this purpose, even though it's not exactly 220 ohms, it's no big deal, honestly. As long as it's within a 5% range of the expected identified resistance value, then we're still fine. And now what happens if it's too small? We just want to identify that scenario. So I move the decimal place over, and so now I'm representing this as 20.21, and I'm losing the 9 here. Let's go a bit higher. So now we're at 0.1. So the reason why it's at 0.1 is because it's not precisely measuring the smaller decimal values. And if we go too far, then it'll just say that it's 0. But if it's too big, then it will identify it as a 1. Okay? So this is how you use a multimeter to identify, on this side, resistance. On this side, the same concept applies using voltage. And then you don't want to use current. There's a different scenario to use when identifying the current value. The current value, but it's a bit more risky because there's a chance you could fry the circuit. So it has a test bulb just in case. But anyway, enough introduction into multimeters. Identifying that this thing is a 220 ohm resistor is important. In fact, it was so important that I had already known this, and I wanted to demonstrate how you could probably check the resistance values in real life. Okay? So, sorry, let me put this aside now. So let me complete a circuit of some sort using my breadboard. Okay. So the first thing we're going to need to start lighting this LED up, we're going to have the power be distributed from the power rail onto, let's say, row number 10. Okay? Now, the first thing I do for an LED is I have to attach the resistance before I attach the LED. Okay? So because this is horizontally moving the current, then I can continue moving it by attaching the resistor vertically. So what happens here is that currently the values, the circuit is going through this wire, hopping over to this resistor, and now we're in row 14. If you're on Tinkercad, you can find resistors on the right-hand side. Probably see it right here. Drag and drop. So you see you can't exactly, because this is in the same line, it's not going to change the circuit. It's not going to complete it. It'll short circuit. And once you place the resistor, I'm just going to leave it like that for a second so I can show you what to do. We're going to make this thing turn into a 220 ohm resistor by changing the settings of this thing. It doesn't change the color to exactly what I have here, though, so that's fine. Now, on the top left-hand side, we're allowed to rotate the object in the manner like so. So that way you can get the adjustments that you want. If I want to attach the wire now, then I can grab the power rail and then attach it onto this. I said row 15, right? Row 10? That was row 10 earlier. It doesn't matter. So now it's going to go into this resistor, and then now I'm allowed to place the LED. Okay? Okay. So now, how do I want to connect the LED? Actually, an LED is, as many people probably demonstrate, it is it is polar. It is specific to one direction of current. Okay, so the long side right here is referred to as the positive side, and then this here is gonna be referred to as the negative side. So because the plus right here represents positive, then we want to attach, we want to start and put the positive side into line 14. Okay? The negative side can go into the next line, line 15, because these can fit right adjacent to each other in rows. So I'll go ahead and put it in like this. Okay? Now, I'm in row 15 now, and I want to go to ground. This is the complete circuit. Okay? So all I have to do is attach a wire from line 15 into the ground. So I'm going to do it like so. Okay? So remember, mine's not wired up yet, but the second I plug it in, then it's going to work just fine. No coding whatsoever on the Arduino yet. We're allowed to make this thing work as a source, a voltage source, directly through these power pins. Okay? On Tinkercad, you can finish the same thing. The LED, it's a bit it's displayed differently. The anode, or the positive side, is on the right hand side as on drawing it. So all you gotta do is flip it upside down, and then now you have the correct description of it. Okay? Now you want to grab this pin and then attach it to ground. Okay? And that should complete the circuit. So for me, if I were to show that this thing worked, now I just gotta do is plug it in. Okay? So when I plug it in, voila, it lights up. For you guys online, what you have here is the start simulation button. If you go ahead and click that, you can see that it's on. Yep. Stop the simulation, it turns off. Fantastic. So now I want to ask right now, are there any questions so far? Is anything going pretty good? I hope that so far I've explained just the basics of how to deal with the breadboard and how to deal with the pins on an Arduino, basically. The basics one. We're going to up the ante in just a second. So right now, this is open questions for maybe a few minutes or a minute or two. And I want to ask you guys, is everything going good? You guys go ahead and type in the chat on YouTube, and I can see that would be going on. Okay? Any questions? Otherwise, I'm probably just going to go ahead and move on to the next section, which will be making the counter. Okay? So, what do I mean by a counter? So, if I start from 0, then I want to go and increment, right? I want to count 1, 2, 3, 4, 5. But how would I know that it's counting right? Well, I want to display it using LEDs. The best way to represent it is in binary, since that takes the least number of LEDs for a good number of values. So, there are several different ways to convert a number from decimal to binary, which we'll get to later, and that is the method I'm going to use to display each bit, each 2's place for each of the LEDs. So the first one will be a 1, the second one will be a 2, the third one will be a 4, the fourth one will be an 8, and then so on. So let's go ahead and keep going. All right. So now, looking back here, I have my LED and it seems to work just fine. Okay. Now what I want to do is start establishing how I'm gonna layer this thing out into the Arduino here. Because these are digital write pins, I'm allowed to send a signal of a 1 or 0. So more than likely, I'm going to send each signal to represent if this number has can be written with a 16. I'm going to go ahead and display that 16 LED as on. And then keep going down the list until I get to my ones place, and then the number is fully represented in binary form. So I suppose I can remove this, this LED and disassemble my circuit. For you guys, I think you can just grab and delete them as you go. So let me click this wire right here, delete, 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 delete. Okay, I still have my power rails though, so we'll get to this in a second. If I want to use these pins to write to each bit, I want to say I need to establish a connection from these pins to light the LEDs up. So I said earlier that it's true that you need to have a resistor before an LED. So we need to establish the pins out, attach it to a resistor, and the resistor attaches it to an LED. Okay? And then all of those LEDs will be attached to ground. Okay? So that's why I have this right here. So you can have an infinite number of resources online on the simulator to throw things out. I do not, and I have to grab them out as I go along. Okay? So I'm going to have first 4 LEDs. Okay? I can pretty much attach them anywhere as long as I can get them working. Okay? Let's see first. I want to have wires connecting pin 2, 3, 4, and 5 to be the first 4 bits of 4 LEDs. So lucky for me, I already have, I had designed my own wire, which is correctly colored at the ends, so I won't be able to mess them up. To be fair, I probably could have used less heat shrink right here, and this is just my way of conveniently wrapping things together. So if I go ahead and plug them into lines 2, 3, and 4, and 5. Let's see, lines 2, 3, 4, and 5. Then I can conveniently place them adjacent to each other. This is just setting the wires out from these pins 2 to 5 out into my breadboard. Okay, I do not need the power rail yet, so really I don't need it except ground. I always need ground for these things. So if I think this through, these LEDs are going to be put adjacently to each other in a very nice way. So let me go ahead and set the positives and the negatives on the same pattern. Okay. So on the right, on the tallest most side, I'm going to have my is going to represent the highest digit value. Okay. And this is also where I'm going to have the let's see. This is also where I'm going to have the positive, each of these pins attach into. So right here, right here, right here, and then right here. But on the other hand, right here, all of this side, I guess we can see this as the odd sides. 14, 16, 18, and 20 are going to be the voltage in, and then 15, 17, and 19, and 21 are going to be going to ground. Okay? So let me establish them in these pins in the same orientation. So I want to have them into lines 14, 16, 18, and 20. Okay? For you guys, you can go ahead and just touch the wire over. (14, 16, 18, and 20). Now, I need to establish too, though, that even though these things are in the same row, because of this bridge right here, they are not in the same, they are not connected. So even though they look like they are not. So I'm gonna be a bit smart and use the resistors as bridges from this side to this side. Okay? So if I do that, I'm gonna have the first resistor attached from this one over here. Okay? And then skip a space, and then that should be right there. Okay? Skip a space, it should be right above that one. Okay? Skip another space, and there should be one like that too. Come on. Wrong row. Alright. So now these pins are going to be somehow coded in a way so that it'll send a signal out to these rows, and now I have to attach these LEDs out into the ground. How can I do that? All right, so because the right below this top one, this resistor right here, into line 15, 17, 19, and 21 need to go to ground. So how about I daisy chain them in a way so as I keep going down, I'm basically adding them together, and then we'll go down into ground. What I mean by that, I'll show you in just a second. All right. So I'm gonna bend my LEDs out just a way. Okay. I'm gonna take this 15 pin, row 15, and I'm gonna attach it to row 17. Because they're going to ground, this is my first daisy chain. Okay. I guess now is a good time to actually update Tinkercad. So let me go ahead and look on here. How do I have it before? Well, I had lines 2, 3, 4, and 5 attach out into LEDs. So let me go ahead to line 2, establish that, skip a space, line 4, 3, 4, and then 5. Okay, and I did say I want resistors connecting and bridging them to this side. So by default, these are 1 kilo ohm resistors. You want to change them as you go along, or what you can do instead is that if you have one highlighted, you can change this one and then just copy and paste each of them. So that's kiloohms. I want to change it back to ohms. Okay? So I'm going to copy this. I lied, get rid of these ones. Copy, paste here. Paste here. Paste here. Okay? And then these LEDs right here. Oops. I'm going to go ahead and grab these LEDs. Remember, the long side, the way I have it oriented, this cathode, the negative side is in this row. But because the simulator has them rotated in a way where it interrupts our flow right here, we're just gonna go ahead and have the topmost side be the ground pins. Okay, so if I do it this way, then I can establish the connection. This is getting power, this is getting power, this is getting power, and this is getting power. Now all of these other rows need to go and to the ground. So I'm going to daisy chain it like this. Bam, bam, bam. And then I can make this thing go out farther. So I wish I can show you the circuit diagram in this, because it looks really neat. Actually, I do have it. I'll establish that later. So what you do is you do this, and then now all these are connected. And now this is basically everything needs to run home into ground, and everything it will be good. Okay, so I'm gonna make this thing go to ground. To emphasize it, I'm gonna change it to black, and now all of this is a completed circuit. Okay, so I'm gonna keep that up for you guys for a second while I go ahead and finish my side of the Arduino. Basically putting in each of these pins. I dropped my. Oh no, I dropped my wires. That's unfortunate. Let's see. Where did you go? Darn it. What's unfortunate is that I have a room with carpet, and so whenever these things fall off, I can never find them. Ever. It's really difficult to find and see them. Alright, that should be enough of them for now. Darn. A minor setback. Just fine. Alright. So let me go back over here to the live video. So what I'm trying to do is I'm trying to connect these ones down into one super ground wire. Not that that makes sense, but come on. So you might realize that wiring on the simulator is probably a lot easier than wiring in real life. And that's because it is. Okay. So now that this thing is going to be the ground wire for all of them, I got to make sure this thing connects into ground over here. So I'm going to go ahead and attach a bridge across over here, and then I'm going to attach this line into one of the pins that are attached to ground. Okay? Okay. So you might notice that these things are lighting up already. And they are binarily counting, and that's only because I had already programmed this Arduino with the what we're gonna do together in a second. So, as you can see though, it is counting correctly. But how did I do it? If you go ahead and let's change it to the simulator. If you go ahead and start simulation, you'll notice that nothing happens. That is because you have not established anything for these wires yet. Okay? You have not established that pin 2 should be writing out a signal, or pin 3 or pin 4 and pin 5 or anything. Okay? So how do we do that? So these Arduinos, because they're connected via USB, they have their own writing software called Arduino IDE. What the IDE does is it lets you program straight into the Arduino in a way where it'll remember it the next time you boot it up. Okay? So, for the simulator, you don't need to worry about this. Instead, you need to look at the top right-hand side next to simulation, where it says code. Okay? So by default, you should already have blocks established. You don't want this unless you want to be a bit easier on the eye. I'm going to go ahead and change this to text. So if I change this to text, this is the standard way that we usually write Arduino IDEs. Arduino C++ code and upload it straight into the Arduino. Give me a second. Let me find more wires. I do need my wires today. If I can't find them, then I'll probably just find other ones to use. They went everywhere. Goodness gracious, I still can't find them all. Alright, so that'll be my spring break project, is finding these tiny wires. Okay. So what does it look like for me? Okay. So I have this scene right now where we can see a live preview of the Arduino. On the other side, we have the Arduino sketch, the program that we have to upload the code to, and you have me. So me is just for fun, because it looks cool. Okay? So if I want to program for the Arduino, let me go ahead and find the window for it. Okay. And if I were to type something in here, you should be able to see that I can get it right there. Okay? My keyboard's tucked away in the back too, so that's why I'm reaching over a bit. Otherwise, I'd probably set this up where it's a bit closer to me. That should work out, I think. Okay, so if we want to show the see the pins work out, then we could probably establish what number we're referring to. So I'm gonna make a global variable called int count, and I'm gonna set this equal to 0. I suppose you can make this an unsigned int. That way, it saves. It can go and reach the highest value of an integer, instead of splitting half of it with negative potential, with potentially negative numbers. So this will be the number to display to LEDs. Okay. I also want to establish programming for the Arduino is also a bit of a task, because even though I established a correct circuit, I have to make sure that I'm coding smart. If I go ahead and write things in a way where it's very very specific and not general, then I won't understand any of the code. So that's why I'm gonna make an array where each of these digits is gonna be the pin that I'm referring to. Inside the array is gonna be the pin I want, and the index of the array is gonna be the decimal place. If that makes sense, okay? Or I say decimal, but the digits place, okay? So I'm gonna make an int array called digits, and I'm gonna set this equal to specifically the array. I know for sure I'm dealing with pins 2, 3, 4, and 5. So if I write 2, 3, 4, 5 here, then I have the array referring to each of them with the correct indexes. Okay? So while I'm doing this, I'm gonna go into setup here, and I'm gonna write a while loop where if I'm not at the end of this array, then I will establish a connection I will establish each of these pins correctly. So actually, I suppose I should also add an integer called I want to call this is going to be the number of digits to display, or like the size of this array. How many digits am I talking about? My maximum capacity of digits. Which is different from what I said up here with digits array. Basically, I want to know if how many total LEDs do I have to deal with. That is what I need to be worrying about. But I don't have to worry about it quite yet. Let me say this. I'm gonna make this end number, and we're gonna start it at 0. Okay. So this is just my wacky way of trying to establish the while loop. We will write it right now, where while we're going through this thing, we're going to establish the pin modes. That's the function we use. We have to say which pin we're at, and we have to say whether we want it as an input or an output. Sometimes it's written something else in the second argument, but generally you don't have to worry about that. It's either input or output most of the time. So digits of the argument number and number, and I want each of them to be outputs. And output is written in all caps. Input would also be written in all caps as well, if you want that pin to be an input. So what do I want to do to go through the end of this loop? While I'm not at the end of the array, then I will be establishing pin modes. The second I hit a null character, then I'm at the end of my array. Now, I will say if digits of end number is not equal to null, meaning is my array pointing to anything of null value or not? Is it empty? And if it's empty only if there's nothing past it. Okay? So basically, end number is going to be our index iterator. It's going to be our iterator. Okay? So because I'm iterating in a while loop, I have to set the increment condition inside the while loop as well. So that is why I'm going to have end number, and this is with end number plus plus. So that way, the next time I go through the loop, I'm going to be incrementing by 1. And the first time I go through it, I'm going to be establishing index of 0 of the digits array, which will be starting at 2. So this is just establishing the pin modes. And if you have a larger array, let's say this is 3, 4, 5, 6, 7, 8, then it would be a general case that'll help things out. So, and we also have a number in the end as a global variable, which we can use to say if we're not at the end of, it'll be a bit safer to write the number as the number of digits, or the number of LEDs. And end number should be also the number of LEDs at the end of this loop. Okay? So that's just setup. Setup is the first thing that you do when the thing boots up. Loop, what do we want to do to this? Well, I want to establish that this number I'm talking about, so this count, remember, count is our unsigned integer. If count happens to be a number it can display, which it should all the time, then I want these LEDs to light up. Okay? So, let me go ahead and briefly explain how I want to display these numbers. So, there are several ways to convert the decimal from binary, written in here, into a decimal, or in a binary form, decimal to binary. So the more technical way of converting a decimal number to binary requires you to subtract that base power, the power of 2, from the number, and you identify whether the remainder is, if you can keep grabbing that remainder and subtracting down. For this though, it's a bit taxing to keep things in check. So instead, I'm just gonna be writing it in a way where we're just gonna take the modulus instead, and that's probably the most common way to do it. So I'm gonna say count is already established what it is. So I want to say inside the loop, I want to see whether if count modulus, well, how would I know what the maximum digit I'm dealing with is? Because I have 4 digits here, then I already have what my number of digits value is, which was the end number I had earlier. So I could say power 2 to the end number. Okay? If that number is the modulus is greater than or equal to. Now, let's say we're talking about the number 16. Okay? I said earlier that you would subtract 16 from okay, let's say the number was 18. I'm sorry. So if we had to subtract 16, and if we still have a positive remainder, then we're allowed to write 16 as a decimal number, as a binary number. We established that the 16th place is going to be lit. For this version, using modulus, if I have to say it correctly, if my remainder is going to be a power of 2 to the n number minus 1, then that means I have more than enough to get to the next number, because otherwise I'd be out of luck. I'm probably explaining that incredibly incorrectly. I don't like this version. I still don't understand this version. But the way I understand it is you're checking to see if the modulus of this power of 2 is greater than or equal to the power of the smaller digit. Okay? What does that mean? Technically, I don't know. I wish I learned this a bit more, but that's what we're gonna do. So see how I'm writing n number? I'm gonna make this as generic as possible. Okay, so basically all you need to do is, if you have the count, if that power modulus is greater than or equal to the previous digit's modulus, I'm sorry, the 16 or something, then what you can do is digital write end number, I'm sorry, digits of n number Sorry guys for the severe halt in my enthusiasm. This is the part where it just gets annoyingly simple, or annoyingly technical, and I don't like it. So, all right, so we're gonna write into that pin. We're gonna write it as a high, meaning if the number is modulus with a positive remainder, then what we want to do is write that it's legal to write. Else, we want to write digital write digits of n number too low. All right. Cool. All right. So what we just did is that we're checking the very last digits place, which I have here is going to be 2 to the 4. I'm sorry, 2 to the 3, which is going to be 8. We're going to check to see if that is writable, and only that digit place. We're going to write an LED to it. So what I want to do before this is make a for loop. Since we have the number of digits to talk about, we want to increment it in a way so we can go down. So how would I do this? So what I can do is say if for int I equal to 0, I is less than end number, we're gonna go up. Now I kind of bamboozled you and I lied. We don't want end number to be written. We want I. Okay? So every instance where you see end number, we're going to write I, because I is going to be changing, so our index can be pointing to the correct place. Okay? So if we do this, then we should be writing out the number correctly. Then, at the end of my final loop, I'm going to make count increment by 1. And I'm going to have a delay of, let's say, a fifth of a second. Okay? So what I can do is I can just grab exactly this code and show you what's going to happen also in Tinkercad. Okay? So let's switch. In Tinkercad here, the simulator, I want to switch this and paste my code. And now it should be able to work the way I want it. Count is going to be counted every so often, and we're going to be able to start it. Oh yeah, that's right. So I lied as well. I know what happens here. What happens here is that even if I want to compile and upload this code, the modulus is written. The modulus is going to be a double and not an integer. So to just get around this, we're going to do round. We're going to round this power value. If it's greater than or equal to, just to make sure, the round of this power value, then we should be fine. And what that does is it makes this number go down to the closest integer. And if it's already an integer, we don't have to worry. And it's always an integer because 2 to the power of a positive number, I'm sorry, not a positive number, 2 to the power of an integer should always be an integer. So that way we can make this modulus operator work just fine. Okay? So now, if I copy all this code again, I'm just going to upload it onto Tinkercad. Bam. That small edit. Start simulation. Probably see already that this thing is going ham. Okay? And also, it's also off by 1 bit. Why is that? Well, that's probably because the way that I wrote it. How did I write it wrong? Let's see. So if we look here, for the first instance where I want to write the number, digital write of I is going to be high. I was already starting at 0, but it should be the first one we're talking about. It's right here. I minus 1. Okay? That's bad. I minus 1 when I is already 0 is not going to work right. So instead, what you could probably do is say I plus 1. Oh, I have to stop the simulation. I'm sorry. Let me go back to this one. If I want to say this correctly, I plus 1, I. So if this number is written with the modulus correctly, then we have so let's check the first instance. So if count rounds 2 to the 0 plus 1, so 2 to the 1, which is 2. So in other words, count mod 2 is greater than or equal to 2 to the 1 is 1. 2 to the 0 is 1. So if this number is greater than or equal to 1, then you write that digit down. Does that make sense? If the modulus has remainder 1 for modulus 2 has remainder 1, it means that the ones place is active. Okay? That's what this says for the first iteration of I equals 0. So with this small adjustment, then we can correctly counter it. Okay? So now, if I start the simulation, I'll show you right now. If you start the simulation, then it should be counting from the right digits place. And voila. And the reason why it keeps going up is because the number is still technically counting, but we're not displaying the 64th place, the 32th place, the 128th place for these higher numbers. But it's still technically correct to write that the modulus is correct. It can be displayed. And that's only because of the limitation of these first 4 numbers. All right, so if it works on here, then it should be able to work on my Arduino here. So because I have it connected already, all I have to do is go to Sketch and upload. You can't see my my pull down window, but there is a shortcut with by pressing Control U on inside the program. So first thing I got to save this sketch. So when I upload it, you see on my screen right here, it is counting the way I want it to. And just to make sure, let me make sure that this thing is counting correctly. So I'm going to change the delay from 1/5 of a second to 2 seconds. And so what I should see is that each of these things are counting every 2 seconds. 1, 2, 2, 2, 3, 2, 4, 2. All right. So that's cool. I found a way where I want to write from the Arduino out to these pins, and I'm displaying the number in binary. Granted, the way I did it is probably a bit bad, and there's a lot of adjustment. And this is also a lot theoretical because I'm trying to convert a number that's not too useful, and I'm not doing too much hardware. But I think it's a pretty neat way of trying to get programming and hardware together in a way where it's kind of cool. I like it. Am I done with the workshop? Let's see. Actually, I kind of am. What I was going to do next is I'm going to add more LEDs, so then I have enough space to deal with things. And also get into scenario debugs. Okay? So actually, yes, let me go ahead and add one more pin that I want to talk about. I want to have one more LED place. Okay? So I'm going to go ahead and attach into the 6th pin right over here. And then I'm going to attach another LED into this one. I'm going to have to daisy chain it correctly, the right way. So let me go ahead and add this wire right here. Give me a sec. All right. And then the only thing I'm connecting now is the resistor right now. Okay? Bam. So now this LED should be connected to the rest of these LEDs. And I just got to change my code a bit so I can understand what is going on right here. Okay? On the simulator, you can pretty much just add another LED and attach it the same way that we just did already. So, let me change to the IDE. In the IDE, I have a scenario where I have 5 pins, okay? So now I have to update the number of digits I have to include the 6th pin or the 5th number I'm wanting to deal with. Now, pretty much everything here should work the exact same. So let's go ahead and see what happens, okay? If I upload this, then what happens? Well, okay, I'm counting 2s. Oh, I'm sorry, let me change the speed of this thing so it's a bit faster. Let me change it to half a second. Okay? So it's counting. Okay. What happens when it reaches the last one? Cool. It looks just fine. Now, I have a fun thing to tell you. Even though that this is programmed correctly, you need to make sure that your array, when we went through the while loop, am I talking about the right number of digits, right? I have 5 digits here, but do I have my end number, is it actually 5 digits? Before it was 4. So what I'm going to go ahead and do is I'm going to open up the serial monitor. What the serial monitor is it's a way for you to read it like it's a console. Read any logging information, like errors or just identify things. So let me go ahead and grab that right now and show you guys what that is. Okay. So, sorry. I'm sorry. Oh, is it already on it? Oh, it is. Okay, never mind. Then I don't have to figure out how to add that scene, that display. Okay, so what I want to do is when I'm done with this setup loop, I want to figure out what number is. So what I want to do is set serial dot print, and what it'll do is it'll print whatever I want inside of this thing right here. So I want to print end number. So when I do that, all it'll do is that it'll basically log it in itself in the Arduino, and we can read it from the Arduino software. I'm not sure how you can do that in the Tinkercad yet, but I did not try it. Alright. So let me click the reset button and just see whether we get something right. Or anything at all. Alright, it's not showing up for me. Instead, we're going to go ahead and cut this and put it in the loop, so that way every single time we're reading it for sure. And we're also going to add an end line. Print line new. So that way it's not just going across the console. It's not doing that for me. It's not debugging for me. Oh no. Oh no. Why is that? Serial monitor. Oh, I'm sorry. Yeah. So what you have to do is, I had a semicolon in a place I did not need. What you have to do is you have to set the begin state at 9600, and that can be done in setup. So the first thing you want to do ever in setup, let me close the console real quick. Oh no. Okay, there we go. All right, so if I have in the setup, I have to establish that serial begins at a specific spot, and almost all the time is going to be at 9600, and that's just the very first thing you kind of do. Whenever you're trying to get things to debug, you always want to add this. What does it mean? I don't know yet, but it's fine. So now I'm going to go check serial monitor. So if I add serial monitor, okay, so now I have 6 here being shown, but I only have 5 bits. Is that right? Well, that's technically right, because the last time you go inside the loop here is back up and into the go back up, and then it checks the condition, and then it says, all right, I'm done. So end number is technically counted more than once, but that's perfectly fine because it's not that big of a deal. So actually, this is weird, because the last time I had an issue with this, I did not have 6 being an issue, because in the last 2 elements of the array, index number 6 and index number 7 in my array, I had thought that each of these arrays were written in a way where it allocated memory in powers of 2. And because of that, I did not want to risk the scenario where having my last two bits of information in, let's say, this 6-bit array, sorry, this 6-element array, because it's saved in memory as a power of 2, that meant that there were 2 extra bits available for memory shenanigans to come into fruition. So if that was the case, then it would not be the index would actually be written with a value instead of null. And because of that, I was skeptical and debugging last night, trying to figure out why it was the case that it kept overshooting. But it seems that it's perfectly fine to keep it this way. Because yeah, it allocates memory, but it allocates enough memory for you to do this. To have an array specifically 6 elements in it, or in my case 5. So that's actually good then. But otherwise, if you had an issue, you can go ahead and use serial console debugging, to identify if you're doing things correctly. That is what I would have done. Okay. So the only end goal of this is to add enough numbers to this thing and make sure that this thing works. But besides that, I do not have anything else to show you guys. Of course, there's a whole lot more behind Arduinos and what you can do with them and what you can write and play with. But it's probably better off for you guys to explore on your own, especially given that I gave you guys the simulator. So you guys can play with it as much as you want in your own time. I believe that everyone can probably play with Arduino as much as they want. I think Arduino is a super neat resource available to everyone. It is open source, so if you want to help improve the way that the Arduino is circuited, if you think that it's better off to establish more breaking the limits of this thing, there's a lot of things you can do with the Arduino. You can make robots work, you can make servos work, you can make your own water garden controller with it. So you can, depending on the time of day, it always waters the garden using a bunch of sensors and stuff. Now, to be fair, it is a bit expensive, but that's only for the hardware. You can always play with the software as much as you want, and they already have hardware elements integrated in software form. That is free and available to use. So if you, of course, it's still better to want to play with it in real life. But for the sake of demonstrating what we can do together, I believe that we have a good resource on our hands given the internet and the hardware available to us. And the technology is already in existence. So you don't have to have real hardware to play with hardware. You can always use it online and have a simulator. Besides that, I do not have anything else that I really can say. Besides, I want to thank everyone that came to this workshop. I want to say thank you to my friends who are encouraging me in their own ways. I want to thank the CSE Club for hosting me and having me on the platform. Subscribe to the channel if you're not already, so you can learn more. You can learn about more workshops later on in the future. The next one is coming up next week. At just about the same time. I'm not too sure when. Check the newsletters, check things out, and I shall be just here for more questions. Besides that, you guys are free to go. Have fun with Tinkercad online, with circuits by Tinkercad. Establish an Autodesk an account. Autodesk also does a bunch of other things. If it's the right Autodesk, I believe they also have 3ds Max. I think that's right, which is more of a software for physics. It's like a physics engine, but also like a 3D modeling engine, I believe. I don't know if it's the right Autodesk because I already had an account with them and I had 3ds Max in my past. But yeah, all right. I shall be open and available right now. I suppose I can check out the Discords if anyone's on it. I sound like an old lady. Is anyone on the Discords? Who's doing things? Who's doing what? Oh, that's right. And because of the delay, I don't know when things are happening. Okay. I guess I can briefly demonstrate to you what I used to make this shot pretty good. So what I have here is my Canon Rebel T5 connected to my computer, and I have it on a tripod. So let's see this scene right here. So if you come over here, I can show you that I'm dedicating my best camera for getting the shot of the Arduino. And all I have software-wise to get the input from the camera, Canon already has their own software for remote shooting, and it lets you display it, granted at 15 frames a second, the exact picture of your camera. So because of that, it's allowing me to get close like this and be able to record this live stream really well. Of course, I'm dedicating a lot of lighting to this thing as well, which is why I'm not using a good camera, but I'm using an okay camera for this. But besides that, I have a microphone which helps me. Do these studio talks. I have a magnifying glass light, so that way I can also do these things. But for this video, for this workshop, I didn't want to show how the how it looked through. It's not ideal for the video. And then on my other side is more lighting. But yeah. If anyone has any other questions, then I'll be here available. We're gonna submit this video and upload it to the YouTube anyway, so go ahead and have fun with that. But if we don't have any questions, I'm ready to turn things off. I'll give it a second so that it can catch up with you guys and I can see what you guys are saying. And also tell me how my performance was today. I don't know. I'm not the best explanations. I'm not that good at explaining like code that I'm not familiar with. Otherwise, I'm not a bad programmer, I swear. But it's not the fault of the algorithm itself. It's probably just me. Otherwise, I would have used another algorithm, and I probably would explain more fun things in the future, like OpenGL. That was really fun. Other math things that are fun to me, instead of like the hardware side of things. I can explain it pretty well, but I'm not. I'll look forward to wanting to do a workshop where it's more mathematically intuitive. Okay. So if we don't have any other questions, then I'm gonna go ahead and turn things off. Thank you so much for watching. Again, subscribe to the YouTube channel. Go ahead and click the like button. Gives us an idea on how much people actually enjoyed this workshop. And have a wonderful weekend. That's it. Goodbye.